Hello, I'm Dr. Deepthi and we are looking at different concepts from maths under the heading Decreations Mathematics. Now, in the broad topic of linear algebra, there is a very important subtopic of matrix or matrix, the way you want to pronounce, and the plural being matrices. Let us have a look at it and try to understand what it is exactly. Typically, when students are asked the question, what does the word matrix remind you of? And most of them answer that they remember the movie, Keanu Reeves movie. So let us try to understand whether there is any connection between Matrix movie and matrix from linear algebra. And the question is not absurd because the answer is yes, there is a connection between the two. And what is the connection? The movie contains digital images, and you know that digital images in a computer are represented by pixel. I'm sure you know the word pixel because when you go to buy uh, a mobile phone, typically one of the specifications is the resolution, the megapixel. Mega, of course, is just 10 raised to 6, it's a prefix. So everyone is concerned with that. So I'm sure everyone is familiar with this term. Now, if you think of a digital image, for simplicity, let us try to think of a grayscale image. So basically no other colors, only black and white and its combinations. So that image will be represented by a pixel matrix or matrix. Each pixel of that image contains one matrix element which is integer, and the numerical values in pixel presentation change from 0 to 255. So if it is completely black, you call it 0. If it is completely white, you call it 255, and in between there is a gradation. And in fact, when you try to process an image, nowadays everyone takes photos with mobile phone and then you want to edit it so that it comes out to be the best possible. So especially if it's a selfie, you want it to look the best. So you try to edit it. So what are you doing when you're editing an image? Basically, you are editing this particular matrix. Well, I won't go into too much details of that. We will maybe have another separate episode for it. But for now, you can remember that matrices are very relevant to you. If you think of real life, they are relevant in terms of digital images and pixels. And even if you think in terms of real life, there are several applications. Let me show you one simplest application. Let us imagine that you have been given description of fruit boxes, and try to just listen to the description first before you look at what is there on the screen. There are 3 fruit boxes and each one contains some mangoes, some apples and some bananas. We do not know the weight of each of these fruits, and our aim is to find out the weight of mango, apple and banana here. Just imagine that. So if there is 1 mango, 3 apples and 5 bananas, and total weight is 3 kilogram. If there are 2 mangoes, 1 apple, 7 bananas, total weight is 4 kilogram. And if there is 1 apple, 1 mango, 5 apples and 9 bananas, total weight is 5 kg. Well, that's a lot of information. And if you're just listening to it, and if I try to tell me what is the weight of each of the fruit, it might get very confusing. So instead, we represent it in the way it is shown on the screen. So we are trying to organize the data. So here, this particular structure is a matrix. So you can have a look at its general form. So typically, suppose if it's matrix A, it can be represented in this form where you can see there are three rows. So A11, A12, A13 constitutes the first row, A21, A22, A23 constitutes the second row, and A31, A32, A33 constitutes the third row. Similarly, how many columns are there? Again, A11, A21, A31 is first column, A12, A22, A32 is second column, and A13, A23, A33 is third column. So, it is an array of elements. Each one of them will be called an element. So, you have the subscript one from row and another one from column. So, for example, here if it is, this is first row and second column. So, the subscript is A12. So, this is a representation of a matrix. And if it is represented by row into columns, typically rows are denoted by M and columns by N. So M by N matrix. So here it's 3 rows and 3 columns, so it's a 3 by 3 matrix. Now, if you go back to the real life situation that we were looking at, what did we do? We represented the whole data in terms of a matrix. We had another matrix. This is called a column matrix because you can see that there are three rows but only one column. So it's a column matrix. And then there is another matrix which basically represents the outputs. Essentially what we are doing here is we are trying to solve an equation. So there could be some such situation where you have 4 equations, 4 unknowns and the matrix representation, and you can solve it. There are several other uses of matrices. They are very, very relevant to your real life. To give you one more application, you can have matrix operation to change the data. For example, there could be a vector which when multiplied by a matrix can lead to rotation, scaling, which is basically increase of magnitude, translation, etc. So what is the takeaway of this particular episode? The takeaway is matrices are very relevant to our life, whether it's real life or real life. So they are not some abstract notation. They are here to help us to, I gave you an example of organization of data and several other applications. So this is what a general matrix will look like, and depending on rows and columns you can call it say 3 by 3 because 3 rows 3 columns. Now this is just beginning of the topic of matrices. There are several things that one needs to know. We will be exploring them in the future episodes. Till then, just remember that it's a highly relevant topic for our daily life. Thank you.